Hi, I'm Nate. In this video, we'll talk about one of the biggest challenges facing engineering and data teams. How do you take trustworthy and transformed data and make it available throughout all of your systems while it's still fresh? Over the next few minutes, we'll talk about some challenges with existing approaches, how Materialize can help, and then lastly, some ways that Materialize can simplify your architecture. So let's talk about why it's so hard to transform fresh data. One of the first options you have is going to the source. Where do you have the freshest data in your infrastructure? Of course, it's your OLTP systems, your databases like your Postgres, your MySQL, your Oracle. These databases were designed to correctly and consistently record transactions with very high degrees of concurrency. The problem is, they're not designed to process complex or data-intensive queries. If you start to run these queries on a OLTP database, you'll see a few things. The first is that you can introduce instability. So your database may actually start to crash as it runs out of resources, or you can impact foreground traffic, which can impact your overall SLA. You could try adding read replicas to offload some of those queries from your database, but you're still scaling an architecture that wasn't designed for this type of work. So you'll still see very high latencies. Caches introduce consistency issues, Materialize views also create load, and you're really in this place where you have the freshest data, but your complex queries are fundamentally slow. The next option you have is moving to a system that is designed for these types of queries. Think of your cloud data warehouse. These systems are great for processing huge amounts of data with complex logic. The challenge is how you get the data here in the first place. As you go through your extract, your batch load, your batch transformations, you lose time. So while you now have fast queries, your data is fundamentally stale. Maybe it's an hour old, maybe it's several minutes old. Either way, it's no longer operational. Lastly, you could try something like a stream processor. These systems are great for doing calculations on fast-moving data. The problem with these is they often require specialized talent and can be very difficult to set up, maintain, and adapt. So if you take a step back, what do we really want here? Well, we want fresh data with complex queries that are fast. And we want this without shortcuts that compromise correctness or consistency. We also know that our data typically doesn't live in a single database. We want a system that can work across all of our sources. And we want this with the team and the budget we have today. And one of the best ways to do that is using standard, familiar SQL. This is where Materialize comes in. Materialize is an operational data store built from the ground up to help you transform, deliver, and act on fast-changing data, just using SQL. Some of the popular use cases for Materialize include things like anomaly detection, creating operational dashboards to help optimize some process or supply chain, even delivering fresh context for your Gen AI applications. So let's see how it works. Materialize streams updates from your operational sources. So your databases, your Kafka topics. And it streams this data into cloud storage. So you have great economics and near infinite scalability. The next thing you do is create views. In SQL, you can use views to take business logic and break it into chunks that are more maintainable or readable. If you were to query Materialize in this state, it would look like a traditional database. It's reacting to new queries that come in. It's doing a lot of work when things get data intensive, when data volumes get very large. In a traditional database, when things are slow, the first thing you look to is adding an index. In Materialize, we take the idea of the index much further. rather than indexing tables, we can index the views themselves. So rather than having your reactive mode where the queries are coming in and the database is processing them, you can take a proactive approach. When you create an index in Materialize, behind the scenes, we spin up data flows. You can think of these as data pipelines that are always running. We use what we know about SQL that declares what that view is supposed to look like to figure out the exact minimum amount of work to do on write rather than a large amount of work on every read. This is where the massive performance benefits come in. Queries return quickly and with fresh results because so much of the heavy lifting has already been done by these incrementally and continually updating views. And one of the great things about Materialize is the amount of flexibility, the amount of expressiveness you get in this SQL. The complex joins, the subqueries, even recursion is supported. Another important property of Materialize is the idea of strong consistency. We've built this system with correctness in mind. As updates are flowing through Materialize, no matter how complex these views become, the entire system will always tie out. This combines to let you do things like create live data products using techniques like medallion architectures, where you go from your bronze layer to your silver layer to your gold layer that becomes your final data API that you deliver to the rest of your organization. Another great benefit of using Materialize is the separation of compute and storage. So we talked about the object store, but all of these data flows, all of these pipelines are living in compute clusters. And these can be scaled out. So if you have complex transformations that are using a lot of resources, you can create dedicated clusters just for that work. Then if you have smaller transformations, maybe they're less resource intensive, you can spin up smaller clusters. They'll be isolated. They can all work independently. And if you want to build a highly available system, you can also add replicas to these clusters. So if there's an availability zone outage, your system will stay up and running. Your data flows will keep those views up to date. Lastly, let's talk about how you get data out of Materialize. Materialize looks like a standard Postgres database, so you can query it from a service or a BI tool. But some of the real power comes from extending that idea of being proactive rather than reactive. As changes are flowing through the system, as data is being transformed, you can actually push it out to downstream systems. This enables you to do things like support event-driven architectures or publish updates for historical analysis in a data warehouse. You can even write SQL queries that can subscribe to changes. This is very powerful for alerting workflows. Materialize is a powerful way to create live data services in minutes with the team you already have. Next, let's talk about some architectural patterns that Materialize unlocks. The first pattern is all about running complex queries on operational data. We'll call it the query offload pattern. This one's pretty simple. You have your updates coming into your transactional database. And rather than running your query on the database, you connect Materialize like a smart read replica. And then for your complex queries, rather than running them on the original database, you run them on Materialize, on top of those incrementally maintained views. Now, when your services query Materialize, they can get fresher answers than if they query the primary database itself. The next pattern is about data integration. It's about taking data from many different sources, transforming it, and sending it exactly where it needs to be. We'll call this the integration hub pattern. Here, you have multiple databases. You join them together in Materialize, and then you push updates as they're available. You can also make these available as data APIs that can be queried directly. Lastly, let's talk about microservice architectures. When you have large teams, scaling teams, often you want them to act autonomously, to have loose coupling so they can move quickly and respond to changing business requirements. The challenge with this is in order to get that loose coupling, they often have their own databases, which ends up creating silos. Initially, this seems fine. Because Team A can scale their database, they can make schema changes, they can apply security patches without having to coordinate with Team B. Well, what happens when Team A needs to access Team B's data? You might think you could query this database directly. The challenge is now you're coupled. If Team B wants to make a change to their schema, for example, now they have to coordinate with another team. This really destroys the productivity benefits, the agility benefits that were promised by microservice architectures in the first place. And this is where Materialize comes in. With Materialize, each team can create a representation of their domain as an incrementally updating view. This view becomes the API that they expose to the rest of the organization. These view definitions can be checked in. They can go through the medallion architecture that we talked about earlier. And you can really build up a lot of trust that this is a stable API that can be used by other teams. Now, if Team A needs another team's data or Team B needs something from Team A, it's just a join away. Everything is up to date. Everything is correct. This is a pattern that we call the operational data mesh. In this video, we talked about how Materialize can help you take trustworthy and transform data and make it available throughout your systems while it's still fresh. We talked about ideas around incremental view maintenance and how much power you get by moving from a reactive approach to processing queries to more of a proactive one. Lastly, we talked about some patterns for simplifying your architecture. If you'd like to learn more, please check us out at materialize.com. We can't wait to hear from you.